Hi, and welcome to my talk on 126 years of high-frequency amateur radio innovation. This thing got a little out of hand, so I had to split it into three parts. But you're about to see part one, dating from Marconi through 1929, and I hope that you'll come back for the next two parts after that. I'll introduce myself in the next slide.
Hi, I'm Jim Hanlon, W8KGI, out here in Sandia Park, New Mexico, and I'm privileged to be able to give a little talk to the AWA this year on 126 years of amateur radio HF innovation. I'll step aside and let you see how crazy I am.
If that wasn't bad enough, just wait. I've got more of my collection on in an inside shack that you'll see a bit further down on the presentation, so you can see that I'm certifiably insane. Okay, these are a couple of books that provided a lot of the information for my talk. Not all of it, but a lot. 50 Years of ARRL is probably out of print, although you may be able to find a copy. Or you can go back to QST in 1964 and find the same information. 200 Meters Down is a great story of amateur radio from the beginning through about 1930-something, as told through the eyes of the ARRL. And you might want to get a hold of one or both of these and read them yourself. Well, in the beginning, all scientific and engineering innovation stands on the shoulders of people who have been before us, and it certainly was the same way with Marconi. I'll go back to 1831 with Faraday discovering electromagnetic induction. Loomis certainly should be mentioned. He tried signaling between two kite wires using static electricity. The AWA Journal reviewed that recently and demonstrated that it may well have happened, but it couldn't have signaled at anything near an adequate rate. In 1873, the Scotsman Maxwell developed his electromagnetic theory that so many of us electrical engineers struggle to understand. In 1886, Hertz, in his laboratory, experimentally verified that what Maxwell predicted was actually there. In 1890, Branly developed the coherer, or actually realized that metal filings can be made to cohere in the presence of sparks. And in 1894, Marconi put it all together and invented radio. Popoff was using the coherer in 1895 to detect static electricity lightning strikes, basically. This is a list of some of Marconi's early accomplishments. In December of 1894, he demonstrated radio transmission to his parents at home, first in his workshop and then across the lawn on his father's estate. In 1896, he was in England, where his mother was a citizen at that point in time, Anne Jameson of the Irish Jameson whiskey family. He started off by demonstrating radio transmission for 2 miles. Then the next year, he managed to transmit from the mainland to a ship at sea for 10 miles. 2 years later, he bridged the English Channel, 32 miles, and then in 1901, he made his famous transmission from the south coast of England at Poldhu in Cornwall to St. John's, Newfoundland, over here on the North American continent. That was his famous 3 dots S signal. He was using 35 kilowatts of spark on what he thought was 366 meters at that point in time, 820 kilohertz. It's somewhat questionable as to whether he actually got across on that frequency or on a harmonic, but he definitely made it and demonstrated transatlantic transmission was possible. The picture here shows Marconi's 1894 transmitter at home. The antenna is that copper sheet on the top. It's connected to a spark gap on the left, which was powered by an induction coil in the center, and the induction coil is driven by a buzzer, a telegraph key on the right hand side of the table, and a battery down at the bottom. In 1945, the Institute of Radio Engineers, predecessor to our current IEEE, put out a publication on pioneers in radio, and they recognized, as they say here, that the first amateur in the world was young Guglielmo Marconi, who wheedled and a recorded number of Italian lira from his rather unwilling father for the crude spark coils of the day. Marconi achieved first between tables in his attic, and later between his attic and land on his father's well-kept lawn, the transmission of signals. And as it says, he smacked of the amateur, if anything could be thus. Hertz was doing scientific work, Popoff was the meteorologist, but young Guglielmo was purely and simply the kid, trying to send messages from point A to point B. Okay, here's an overview of amateur radio from the period from Marconi's development up to the First World War, which shut down amateur radio for the duration. Amateur transmitters were spark over that entire period. Receivers progressed from the coherer detector initially up to crystal detectors around 1906, and added loose coupler tuners and finally audion tube regenerative tuners around 1915-1916. Significant events included, of course, Marconi inventing radio, spanning the Atlantic, DeForest inventing the triode, the three-element vacuum tube, Armstrong using it to invent regeneration, and the ARRL organizing the first amateur transcontinental message relay in early 1917. Wavelengths people were using, well, Marconi spanned the Atlantic on 366 meters. Amateurs were primarily on longer wavelengths, which were thought to be best for long distance in the early and mid 1900s. But around 1912, we got stuck on 200 meters and down, which were thought to be worthless frequencies. So in the period from 1905 to 1909, there were quite a few things happening. In 1905, DeForest invented the audion, the three-element vacuum tube we know as the triode, but it was little used for the next 8 years because it was prohibitively expensive. Also in 1905, there were 150 amateurs on the air. In 1906, the Alexanderson alternator came on the scene. It was a mammoth rotary mechanical generator. Only instead of running at 50 or 60 hertz, it ran at frequencies anywhere from 14.2 to 25.8 kilohertz and generated basically low-frequency radio waves. Alternators were built up to 500 kilowatts in power, and there's still one of them on the air in Grimeton, Sweden. SAQ on 17.2 kilohertz goes on the air occasionally. The Pulse and Arc also generated more or less continuous waves, not as as pure as any means as the alternator, but still a lot more coherent than were the damped spark waves. In 1906, crystal detectors came along, both silicon and carborundum, and they were used pretty much by the amateurs for the next 10 years until the war. 1907, a typical amateur station was a Rumkopf step-up coil, a condenser, spark gap, and a coherer detector. Those stations had a range anywhere from down the street to perhaps 100 miles. In 1908, there was a bit of a split between commercial and amateur radio technology. Amateurs started to use tuners, both in their receivers and transmitters, which narrowed the bandwidth of their spark transmitters considerably. Commercials, however, and the Navy did not pick up using tuners for several years. In 1909, there were something like 500 to 600 worthwhile amateurs on the air, and several times that of small spark coils. This is what a typical amateur spark transmitter looked like around 1907. Not too different from what Marconi actually put on the air. You can see on the left that we have a key with a battery and a buzzer energizing the primary of a step-up transformer with pulsating DC. The secondary contained a spark gap, which in turn excited an oscillating coil and antenna circuit that radiated the signal onto the air. In 1910, the U.S. Department of Commerce started to issue amateur licenses, certificates of skill they were called, and the first 502 went mostly to amateurs. 1911, there were about 4,000 amateurs with transmitters on the air, anywhere from 250 to 1,000 meters, which generated murderous interference, as it was called, to commercial stations. So the radioactive 1912 came along and pushed amateurs up to wavelengths of 200 meters and shorter, which were thought to be worthless at the time. And the thought was that would doom amateur radio. Little did they know. In 1912, Armstrong invented regeneration, which would lead in the next few years to regenerative receivers and CW transmitters. In 1914, Maxim and Tosca formed the ARRL, first publishing QST in December of 1915. And by the middle of 1914, there were more than 5,000 licensed amateurs and around 10,000 amateur stations. Here's an ad from QST in February of 1916 showing crystalloy wireless detectors. Most amateurs at that point in time were using either crystal or Audion tube detectors, and also showing Brandy's radio headphones. Probably not too different from many of the headphones that some of us, like me, are still using today. Here's an ad in QST in May of 16 announcing the DeForest 3-element tube, and also showing a rotary spark gap, which was a big part of a transmitter, and I just love the name of Klitzen. You can just hear it sparking with that kind of name. In 1916, there were stations with half-inch spark coils that maybe got out 5 miles, quarter kilowatts that got out as far as 400 miles, and 1 kilowatt rotary spark gaps with galena or silicon or Audion detectors, loose coupler tuners, high antennas that could make 1,000 miles. By the close of 1916, the number of licensed amateurs had grown to over 6,000, and there were something like 150,000 receiving stations. There were manufacturers supplying amateur equipment, and you could even buy some commercial Audion regenerative receivers. This is one of the first Audion receivers. It's actually a regenerative amplifier. You can see from the curves over there on top of the figure the kind of gain and selectivity that you would get by using the Audion rather than just a simple tuner. You added your own detector to that particular tuner, and it covered from 180 to 580 meters. Here's a picture of Hiram Percy Maxim's personal spark transmitter. He called it Old Betsy. It is, or at least was, in the ARRL Museum, and I made a visit there a few years back. The spark itself, which is a rotary, is inside that big wooden box in the middle of the table. It's being driven by the motor on the right-hand side, and on the left-hand side you see the output coil with the antenna coil behind it, just below the RF ammeter. The key there in the center, underneath the plaque in the middle, is Maxim's spark key. That's in the AWA Museum. Now here's a fellow some of you may very well know. This is Bruce Kelly, and Bruce is demonstrating a spark transmitter that is in the AWA Museum. I was quite privileged to get a tour by Bruce one evening back in the 80s. On the next slide, I will show you an actual video of a similar tool that Neil Weigard took at the hands of Bruce as well. But before I do that, I want to call your attention to the call letters that are right in front of Bruce's right arm. You see 8TC down there underneath the motor that's driving the rotary spark gap. I was able to find 8TC in the 1916 amateur call book, and 8TC was E. Russell Whiteman. His location was the Flint Central High School in Flint, Michigan, and he was running 1 kilowatt of spark at that point in time. So it's very likely that this is Mr. Whiteman's 1 kilowatt spark transmitter that Bruce is demonstrating to us here at the AWA. Let's go on to the next slide and take a look at what he's actually doing.
All these other spark transmitters are non-synchronous. That means it sparks anywhere over 60 cycles. This does not. This sparks on the peaks of the 60 cycles.
And that's because of the motor synchronizing?
Well, you're going to find out in a minute.
Okay.
There are 120 peaks, 60 pluses, 60 minuses.
Sure.
The objective is to make it spark on the plus or the minus, never on the curve down or on that slope up. You do that if you have a synchronous motor. A synchronous motor multiplies and revolves on a multiple of 60.
All right.
1800, 2400, 3600. This is 3600, and 6 goes into 36. Now, this one turn brings it to 200 meters to resonance. That's the antenna pickup coil. This is just the way it was taken off the air 70, 80 years ago. Now, you stand over here, you can see it work. This is lethal, and this is the reason we keep the door locked. Now, you want to stand where I am here and shoot in on it.
Oh, okay.
I'm going to sink the gap, as they call it. Circuit, I don't think you live very long.
In case you're CW challenged, what Bruce sent there was a V, which is sort of a test signal, DE, which means from, 2AN, W2AN, and W2AN is the call of the AWA station. Okay, from 1917, or in 1917, before the start of the war, the first message was sent via a relay from California to Hartford, Connecticut in January, followed shortly thereafter by a round-trip message that made it all the way from Hartford to California and back in 1 hour and 20 minutes. Then in April, all transmitting and receiving stations were shut down because of the war. Antennas were lowered to the ground and all radio apparatus was disconnected and rendered inoperative. This is a snip from the AWA Journal in the spring of 2018, showing that amateurs were called to be radio operators for the Navy by the ARRL, and many amateurs did step forward to fill the need for skilled radio operators during the war. Now let's have a look at the post-war period, beginning with the ban being lifted from amateur activity in 1919 and going through 1929. In 1921, there were some 10,800 licensed amateurs. This is a snippet from 200 Meters and Down, written by Art Budlong, W1BUD, about King Spark. And it's the closest thing to free verse that I'll come by in this presentation. I just have to read it to you. Glorious old sparks. Night after night they boomed and echoed down the air lanes. Night after night the mighty chorus swelled by ones, by twos, by dozens, until the crescendo thunder of their stentor bellowings shook and jarred the very universe. 1,000 voices clamored for attention. 500 cycles high metallic ring, the resonant organ basso of the 60-cycle sync, the harsh resounding snarl of the straight rotary. Character, nervous, impatient sparks, hurrying petulantly. Clean-cut, business-like spark, batting steadily along at 30-word clip. Good-natured sparks that drawled lazily and ended in a throaty chuckle as the gap coasted downhill for the sign-off. Survival of the fittest. Higher and higher powers were the order of the day. The race was on, and devil take the hindmost. Interference? Lord, what interference. Bedlam. Well, it could not be utopia. Okay, 1919 to 1929. You can see that some substantial changes took place in this time period. In particular, on the transmitter line here, King Spark started off the decade, but tube-type CW soon came on the scene as early as 1920, and by 1925, Spark was outlawed in the United States, having been pretty well outmoded by that time anyway. Receivers were regenerative mostly for the period, and the frequency line down here at the bottom is interesting. We started off on 200 meters, and by the end of the decade, we had bands that were looking a lot like the present day 160, 80, 40, 20, 10, and 5 meter bands, 6 meter band almost. In terms of events, you can see that we made it across the pond to Scotland. Then we had QSOs to Tokyo and France. Crystal Control came in 1926, and so forth. Let's have a look at some of these things in greater detail. A properly tuned and operated spark on 200 meters was a very broad signal. It could easily spread over 150 to 250 meters. Whereas a tube-type CW transmitter took up almost no space at all. During the war, a 5-watt tube proved that it could cover about the same distance as a half-kilowatt spark. Initially, after the war, tubes weren't readily available, but in 1921, RCA and GE brought out a number of different transmitting tubes, although they weren't cheap. CW was difficult to tune on the old variometer receivers that were made for spark, but in 1921 and 1922, QST published the Reinartz tuner, which was a regenerative receiver capacitor tuned and had no hand capacity effects and was a much better receiver for the CW signals of the day. Here's the 1922 Reinartz tuner from QST, and with a little imagination you can see a regenerative detector in there and a stage of audio. In 1924, QST came out with this one BGF low loss tuner, and as you can see from figure 2 down there at the bottom, it is the quintessential regenerative receiver that many hams used for the next 17 years, up to the beginning of World War II. It has no audio amplifier, but that was certainly easy to add. Now I want to step back for just a minute and introduce to you a friend of mine. The fellow over here in the right-hand picture is Robert C. Higgy. I knew him as Doc Higgy, or Bob. His call back when was 8IB, but he was my friend, my fraternity brother, my electrical engineering professor at Ohio State, and a fellow ham when I went to Ohio State from 56 to 61 for my bachelor's degree. Bob was born in Columbus, Ohio in 1901 and died in 1981. In 1919, Bob caught that doggone Spanish flu, and although he recovered from it, he always blamed it for his poor eyesight. You can see he's wearing glasses here in this picture in QST in 1922. And also he came down with Parkinson's later in his life, which he also felt was due to the Spanish flu. Bob was a ham early on. You can see when he was 11 years old, he had a 1 kilowatt spark on the air in Lima, Ohio. When he was 14, he was in Phoenix, Arizona as 6DM, and he had his 1 kilowatt spark on the air and was a link in the ARRL Transcontinental Relay in Phoenix. I also checked in the 1916 call book, and at that point in time, Bob is listed as residing in Hollywood, California as 6DM. However, he came back to Columbus during World War I, and when he was a teenager, perhaps 17 or 18 years of age, he was serving as a signaling instructor at the Ohio State School of Military Aeronautics. After the war, Bob operated 8IB from Columbus. In 1922, he went to work for the ARRL in Hartford as an assistant editor for QST. Here's a letter that Bob wrote to QST in 1921, and on the left-hand side you'll see a postcard that Bob received verifying that LB Wilkoff 9DF had copied Bob when he was calling 8FT with his CW transmitter. Bob had gotten a hold of a war surplus VT1. It was a receiving triode built by Western Electric. And you can see over here on the right-hand side that he had two circuits that he recommended, one of which on the left is a Hartley, and he was keying it in an interesting way. He was keying an inductance in and out in series with the antenna. I can only imagine that shifted the frequency, and he was doing some FSK, or perhaps he was swamping the oscillator. I don't know which. You can see that his B plus supply, which is in series with the plate of the tube over on the right-hand side of the circuit diagram, was an old 500 volt motor that he was driving. Somewhat slower than full speed because he didn't want to use the full 500 volts on his VT1 because he said it would turn it blue. Also, you can see down in the left-hand side of his circuit diagram, underneath the CW key portion, that he was able to insert a microphone or a buzzer in series with the antenna, so that he was getting on the air with some phone and also with modulated CW. The postcard is dated November 24th, 1920, and Wilcox was telling him that he had heard his CW transmitter and that he was using a 1 kilowatt spark, and asked Bob if he heard his signals. So Bob was one of the very early hams who got on CW. Here's the VT1 that Bob was using. It was originally an audio tube or a receiving tube in an airplane transceiver during World War I. I don't know how he got a hold of it. I wish I'd known enough to ask him about that when I knew him at Ohio State in the 50s. At the same time frame that Bob was operating his ham station 8IB with that VT1 CW transmitter, he was also a freshman at Ohio State, and he put a radio station, an experimental radio station in Ohio State, on the air, 8XI, with 1.8 watts, it was reported. Very likely the same transmitter, since it's the same time frame. From the Ohio State WOSU webpage, it states, shortly before the 8XI license cleared federal approval, OSU faculty had assisted a genius of a freshman named Bob Higgy with the creation of a transmitter to air phonographic records from OSU's Robinson Lab. The headline in the March 8, 1920 Ohio State Lantern, the student newspaper, simply stated, "Latest New York jazz records are heard over Frosch's wireless." The Ohio State record goes on to record that by 1922, 8XI had been replaced with the call WEAO, and in 1933 it was changed to WOSU. Also in 1926, Robert Higgy became the first full-time director of radio operations at Ohio State. This is a picture of Bob. You can tell by his bottle-thick glasses there. I'm sure it isn't his 1920 transmitter, but it's an early shot from the WEAO equipment. Now I have to brag a little bit about New Mexico because that's where I'm located right now. Here's the station in Roswell, New Mexico, that won the Hoover Cup for America's best all-around amateur station for 1921. It was homemade, and Louis Falconi had 4 tubes, 450-watt tubes, that he either used as an oscillator altogether on CW, or 2 as an oscillator and 2 as modulators when he went on phone. He had a couple of 500-volt motor generators like Bob did. He put them in series to get 1,000 volts for each transmitter. He also had a kilowatt spark gap. He used a variometer receiver, regenerative, with 2 stages of audio, and there's a picture of his antenna on the next slide that I'll show you in just a moment. His CW signals from Roswell were reported heard in every state of the Union, all 48 except for Maine that year. Here's a rather blurry picture of Lewis's station. On the left is transmitters and receiver, and on the right there's a picture of his antenna set up in Roswell. I can only imagine what my wife would say if I had an antenna like that on top of our house in Sandia Park, New Mexico today. And here is a penny postcard from 99 years ago, addressed to Bob Higgy in Columbus, Ohio, Radio 8IB, showing how the hams in Akron, Ohio shared the time available to them during a 24-hour day. This was in order to avoid interference from one station to another. In 1921, most hams were still using Spark, so there weren't very many stations at the same time that could occupy 200 meters, and this is what they did in order to avoid murderous interference. So that's what transmitters were like in that decade. For power, early CW transmitters used either motor generators or they simply used self-rectifying circuits, sort of push-pull type oscillator circuits that ran on AC. By 1922, chemical rectifiers were being used, multiple slop jars in series, but they were messy and a little difficult to maintain. Eventually, gas tube rectifiers came along, and in 1923, QST published a definitive article about power supply filter circuits, which helps hams to come up to snuff as far as having a better DC signal was concerned, at least as far as the power supply went. In 1926, the first crystal-controlled oscillator transmitter appeared in QST. Actually, it appeared in 1924, but by 1926, crystal-controlled transmitters were starting to come on the air. In November of 25, there was an article in QST that told you how to orient, cut, grind, mount, and test your own quartz crystal. That must have been quite a job. In January of 26, QST published how to build it articles for several crystal-controlled transmitters, starting off with 210 oscillators, good old low mu triodes, followed by 203A or 204A power amplifiers. In that era, crystals were not cheap. General Radio wanted $15 for a 160 meter crystal in December of 1926. By 1929, there were multiple manufacturers offering crystals, and they wanted anywhere from $4.50 to $45 for them. $4.50 I might have been able to afford, but when you think about the dollar multiplication between 1929 and now, it was expensive to get on crystal control. Tubes were developing quite a bit too in the 1919 to 1929 era. In December of 27, the first screen grid tetrode, the UX222, became available. That allowed hams to use unneutralized RF amplifiers in their receivers or IF amplifiers in their receivers. And it also allowed them to control the screen voltage of the detector tubes that they were using in regenerative receivers for an easy control on the regeneration. Up to 1929, tubes had all run their filaments on DC, but in 1929, AC filament tubes came out. which ended the necessity for battery-operated radios. RCA also in 1929 came out with a number of transmitting tubes, some of which you'd recognize. I think the 866 may have been the mercury vapor rectifier that we all used in the 50s and 60s, a beautiful blue glowing tube. And the UV211 is also another tube that was used extensively in BC375 transmitters. It's a big old triode during World War II. And even now, the audiophiles love to get their hands on a 211. Also, National Radio came out with mercury vapor rectifiers in 29, and Cunningham came out with a 24 and a 45. Transoceanic contacts were quite a feature of the early 20s and later on. In February of 1921, the ARRL organized a program where British hams were to listen for American stations who would call on 200 meters. Unfortunately, the British hams regenerative receivers didn't have any isolation between the detectors which were oscillating in the antennas, so they radiated quite a bit. And there were also commercial harmonics and high noise and unsure frequency calibration. So in February of 21, American signals were not heard in England. However, in December of that year, the Americans sent Paul Godley to Anderson Moor, Scotland, which is on the west coast of Scotland, west and a little bit north of Glasgow. He had a super heterodyne receiver and a good regenerative receiver, and he set up a Beveridge antenna, a long wire, straight wire pointed at the United States, at New England, tuned up on 200 meters. And Godley was able to copy 18 American CW stations and 9 Sparks. 2 British hams also copied 11 of the American stations, and the Americans were even reported heard at The Hague and in Nice, France, by Leon Deloy, F8AB, who will come up shortly. This proved the superiority of CW over Spark and motivated a lot of people who were using high-power Spark to get into the CW business. Also in December of 1921, 6 ZAC in Hawaii was heard by approximately 24 American stations as far east as Wisconsin. And on the 18th of January, 22, 6 ZAC and 6 ZAF in Berkeley, California were exchanging routine traffic. There were trans-Pacific tests ending in May of 1923 with many Americans from all districts except 2, which is northeast, heard in New Zealand and in Australia. In November of 1923, U7HG in Tacoma, Washington, worked JUPU in Tokyo on CW. And the next day, F8AB, our friend in France, who had copied the American stations earlier, managed to work U1MO and U1XAM, Schnell and Reinartz, on 100 meters. The IEEE, in reporting on that particular QSO, said, Deloy's rough, throaty gurgle filled the phones, referring to the 25-cycle source of his power. There were a number of radio conferences that defined and limited the amateur bands during the 1920s. As we mentioned earlier, there was an awful lot of interference between American Sparks and commercial broadcasts and commercial stations with the Navy as well. So in March of 22, the amateurs were pushed up to the frequency range from 150 to 275 meters. And American broadcast was set between 210 and 435 meters. You'll notice, of course, that there was a considerable overlap between the amateurs and the broadcast. So that must have made for some very interesting interference complaints. The very next year, amateurs were moved up to 200 meters and lower, and broadcast was limited to 220 to 545 meters, so that got rid of that particular interference problem. The amateurs were supposedly assigned to wavelengths that were useless. 200 meters and down was thought to be territory that wasn't useful for any distance communications. But the amateurs soon proved that 200 meters was 200 meters and shorter was good for transatlantic, transpacific contacts. So in 1924, the frequencies above 1500 kilohertz were reallocated, and amateurs were given generous allocations in those bands, as you can see. But you're starting to see bands that correspond to some of our traditional ones. We had a band that covers our 160 meter band. We had our present 80 meter band. We had a megahertz at 40, 2 megahertz at 20, and 4 megahertz at the fourth harmonic of 20, which is 5 meters. In 1925, they even added 1 megahertz up in the UHF range. They also allowed us to use phone from 3500 to 3600 in November of 25, and they outlawed Spark in the United States, which by that time wasn't being used anyway. Finally, in 1928, they added what was pretty much our present 10 meter band. Now I'd like to give you one more little Bob Higgy tale. Bob told me this story himself when I knew him at Ohio State. It happened in 1926 between Bob and KDKA. KDKA, as you probably know, was one of the very early radio transmitting stations on the air. They broadcast the November 2nd, 1920 election returns from East Pittsburgh, and they had a 100-watt vacuum tube transmitter on the air at that point in time. By 1926, they had a kilowatt on 920 kilohertz, and up until that time, they had been attempting to support themselves by the sale of Westinghouse radio receiving sets, but that wasn't going too well. So as a part of the new NBC Blue network, they decided to start carrying advertising to support their station. So to pick up Bob's stories, at that point in time, the summer of 1926, a group of advertising and sales people and technicians from KDKA in Pittsburgh came to Columbus, where Bob was living. They set up shop in a downtown hotel, intending to demonstrate to local merchants how well KDKA could be heard in Columbus, to convince those merchants to advertise on their station. Well, when they got their gear set up, they couldn't pick up KDKA. Perhaps because there was a bit of interference from some ham kid that they heard in the north end of town. At any rate, being enterprising, they found that kid, Bob Higgy, of course, and they acquired his services to mimic KDKA. It worked so well in impressing the local merchants that they actually hired Bob. And they took him with him for the rest of the summer to other visits that they made to other stations, or rather to other towns in Ohio. Bob stood in for KDKA when his ham gear could make the scene and KDKA could not be heard. There was a World Radio Conference in 1927. The effects of this conference were to take effect on the 1st of January in 1929, and amateurs lost 6.5 megahertz, below 64 megahertz, in that World Conference. You can see what the old bands in 1928 were over here on the left, and the new bands in 1929 look an awful lot more like our present allocations on 160, 80, 40, 20, 10, and 5 meters got pushed to 6 meters after the war. You'll notice that 20 meters went up to 14.4. We lost 50 kilohertz on 20 in the early 50s when we got 15. So our present allocation there is 14.350 and not 14.4. But the new bands look an awful lot like bands that we have today. The ARRL realized that the transmitters that we had been using on our old wide bands were simply going to not be satisfactory for the new, narrower bands. We had to do something to sharpen up our signals, cut out the drift and the buzz and the hum and everything else. So they commissioned Ross Hull to develop a couple of transmitter designs that hams could duplicate reasonably and easily, and that would give better 1929 style signals. And in QST of August of 1928, he published his 1929 high C Hartley transmitter. You can see it's pretty simple. A single triode. He used a 10 in a Hartley oscillator, that is with the cathode tap or the filament tap going to a tap on the coil L2 there, and coupled to probably ZEP or Hertz antenna feeders with another coil. There are a lot of Bruce Kelly AWA contesters who use this transmitter even today in our 1929 QSOs. In the September issue of QST, Hull published an article on a master oscillator power amplifier transmitter. You can see it uses the Type 10 as a Hartley oscillator, and its capacitor coupled to another Type 10 as a power amplifier. And the amplifier is neutralized. You can see the neutralizing capacitor going from the grid C4 up there to the opposite side of the plate coil. That hopefully prevented the amplifier from oscillating on its own when it wasn't being driven by the Type 10 oscillator. I have built both the Hartley and this MOPA, and I've got to tell you that this particular MOPA, as Hull laid it out, really isn't a very good design. The amplifier is operating at best class AB2 and is more of an isolation stage than an amplifying stage. Power output from the amplifier is just about as much as the power input from the oscillator. So you have to get into some of the 1930s technology to reset the operating point for the amplifier, and also to pick better values for the amplifier tank circuit if you're going to get much in the way of additional power out. However, both this MOPA and the Hartley did have considerably better sounding signals, and were up to the 1929 standards. Hall had also previously produced what he called a growler. It's a monitor and frequency meter, and as you can see, it's just a regenerative detector built into what looks like the kind of can that people used to bring beer home from the bar in. But it allowed you, because it was shielded, it allowed you to pick up your own signal and to listen to it so that you could tell how pure and how stable your signal was. In the 1929 era, most of the receivers were home-built regeneratives. Here, however, is a commercial receiver, one of the first commercial receivers that was available to hams, the Pilot Super-Wasp, and it was sold from 1929 to 1931. It had a screen grid tuned radio frequency stage ahead of the regenerative detector, which certainly provided some isolation and better sensitivity, and also cut down on the detector radiation, and a couple of stages of audio. It had plug-in coils that covered from 600 kilohertz, basically the bottom of the broadcast band, up through 21.5 megahertz, and you could get ham band spread on it if you wanted to. It was described in one review as a primitive shortwave receiver, but performance can be surprisingly good. As far as antennas were concerned in the 20s, from Marconi through 26, most hams were using vertical antennas, perhaps with a top hat, as you saw in the antenna there from New Mexico, and a counterpoise. They were called Marconi antennas, and they were worked against ground. However, in 1926, Dr. G.W. Picard wrote an article in QST telling hams that their signals, their vertical signals, didn't remain vertical after leaving, but were in large part twisted around so that they were horizontally polarized. And at that point in time, hams started using horizontally polarized antennas. And in the later part of 1926, Cruz and Wyndham may be a name you've heard, talked about various antennas, including a Hertz antenna, which is made up of multiples of half a wavelength, and can be fed either off-center with a single wire, which was called a Wyndham antenna at one time. And it can be fed in the center with a two-wire open wire line, which these days tends to be called a center-fed ZEP. And it can be fed at the end with a two-wire transmission line called an end-fed ZEP. The ZEP refers to the Zeppelin airships, which use the end-fed configuration of a half-wave or a multiple of a half-wave wire. And that's where the ZEP name comes from for these antennas. I'm presently using a center-fed ZEP that's a half-wave on 160. And I can tune that antenna up on all bands through 10 meters if I care to. I also can tell you that center-fed ZEP that I'm using is made out of wire that an uncle of mine left in my dad's basement when he left Fort Thomas, Kentucky for California in January of 1942. I've had that wire up in one configuration or another as a center-fed ZEP or an end-fed ZEP ever since I got my novice ticket in 1952. So that kind of antenna does work fairly well. At any rate, if you stuck with me thus far, thank you very much. I really appreciate it. You probably need a break, and so do I. So let's end this as part one for now. At the end of 1929, or nearly so, And you can take me up again in part 2, which will take up in 1930 and go up to the beginning of World War II.